Okay, we're going to be talking about multiplying and dividing rational numbers. The rational numbers we're using in this particular case will be mostly decimals, although obviously we do have some fractions. So let's start to get into it. Okay, we have 4.51 times 3, okay? Right now, I'm just going to ignore the decimals. When I get to my final answer, I'm going to think about how many numbers are on the right of the decimal, and I'm going to swing it 1, 2. I'll show you what that looks like. 3 times 1 is 3. 3 times 5 is 15. Put down the 5, carry the 1. 3 times 4 is 12 plus 1. We end up with 1353. I have two numbers on the right of 0. So 1, 2. And my answer here is 13.53. Okay? So that's going to be our first little answer. The second answer we're going to have, or we're going to get, basically 5 divided by -2. Now there's obviously there's a couple ways to do this. We can just flat out divide, and we can figure out how many times 2 or -2, whatever, can go into 5. 2 can go into 5 twice. That gives us a 4. 5 minus 4 is 1. Add a decimal, add a 0, drop the 0. 2 can go into 10 5 times. Again, it's a negative. So our answer would be -2.5. Or if you think about it another way, 5 over -2 can be decomposed, right? So a whole number will give you 2 over 2. So we can take that and say we have 2 over 2. We can take this and say we have 2 over 2. That's 2. That's 4. We need 5, which means what would be left would be our 1/2. Either way, you end up with 2, or -2 rather, and 1/2. Okay, so that's just another way to look at it. Let's go to number 3. We have 15.6. I'm going to not write down the decimal. Times -2. They're both actually negative, so a negative times a negative will give you a positive answer. If the signs are the same, the answer is positive. So at this point, I've just rewritten it, and I've negated the negative signs, so now it's just a matter of multiplying. 2 times 6 is 12. 2 times 5 is 10 plus 1. 2 times 1 is 2 plus 1. Because I had one number to the right of the decimal, I slide that over right there. My answer is 31.2. All right. For number 4, it's going to be pretty much similar in terms of ignoring the decimals. Excuse me. 432 divided by 12. So 12 can go into 43 3 times. 3 times 12 is 36. Can't do that. Have to borrow. 13 minus 6 is 7. Bring down my 2. 12 can go into 72, I believe, 6 times. And I think because we had one decimal there, we're just going to swing it over right here. And the answer we get is 3.6. For number 5, we have different signs. A negative times a positive. Cool, not a big deal. Do -2.5 or -25 times 7. 7 times 5 is 35. Put down your 5, carry the 3. 7 times 2 is 14 plus 3. You should end up with 17. because I had one number on the right of my decimal, I'm going to swing that over right there. But because I multiplied a negative by a positive, I'll end up with a negative. So this answer is negative 17.5 or negative 17.5. Either way. Excuse me. For this next one, we have negative 32 divided by negative 5. So, two negatives make a positive. I'm just going to divide it. 5 can go into 32 6 times. That's 30. Leaves me with 2. Sure. Add a decimal here. 0 there. Should be 4. 20. Bam. And my answer is literally just that. 6.4. Again, I had the same signs, which means my answer should have been positive. Going into this word problem. Now, here. Oh, excuse me, sorry. Golly, my bad. Says the cell phone company charges Michael a late fee. So cell phone company charges Michael a late fee of $3.84 per day. If Michael is 8 days late, what is the change in Michael's bank account? Okay, let's do it. What is the change in Michael's bank account? All right, well, let's talk about what we know. What we know is that the late fee is $3.84 per day. We also know that Michael is 8 days late. Michael is 8 days late. What do we need to know? We need to know what the change is in Michael's bank account. So we need to know what the change is in Michael's bank account. Perfect. So how are we gonna plan this out? Basically, we're just multiplying, okay? We're gonna get $3.84, although I added the decimal there, you don't really have to, times 8. 8 times 4 is 32, carry your 3. 8 times 8 is 64, plus your 3 is 67, carry your 6. 8 times 3 is 24, plus 6 will give you that 30. We have two numbers to the right of the decimal, so I'm going to swing it and swing it. Therefore, now these are late charges, right? So if they're late charges, unfortunately, it's a negative balance. So we're going to say that the change in Michael's bank account, the change in Michael's bank account was negative $30.72. Okay, next page. All right, so here I'm going to show you that show you something I do with converting mixed numbers into improper fractions. Okay, it's something I like to call walk around Texas. So for this first one, we're going to walk around Texas. I have my TX right there, and as I walk around, I'd perform my operation. So as I'm walking around, I see 2 times 1. That's going to give me 2 plus 1. That's going to give me 3. So now I have 7/8 times 3 over 2. Cool. We're going to multiply our numerators and our denominators. We're going to end up with 21 over 16. Well, here we can decompose as well. I know I need 16 over 16 to make one whole. I can take 16 from 21. 16 over 16. 21 minus 16 leaves me with 5. And that's what's left. 5 over 16. All of this is equal to 1 and 5/16. Going to the next one. I'm going to do the same thing. But this time with my first one, okay? I'm going to walk around Texas. And as I'm walking around Texas, I'm going to multiply my 2 times 4, or my 4 times 2, which is 8. I'm going to add my 3, which is 11. But it remains over the same denominator. So now I have 11 over 4. When I divide, we are doing keep, change, flip. I keep my first fraction. I change my division sign to a multiplication sign, and I flip my second fraction. Instead of 2/3, it's going to be 3 over 2. I multiply straight across. I end up with 33 over 8. Well, let's think about how many times 8 can go into 33. It's 4. That's going to give me 32. What's left? A 1. Therefore, I have 4 and 1/8. That is what it looks like if I were to take 2 3/4 and divide it by 2/3. Now, I'm going to rewrite some of these just so that they're a little bit bigger, but I'm not changing anything yet. So for number 8, I have 3/5 times 2/3. I'm going to look for common factors. 5 and 2 share nothing, but 3, that's their common factor. 3 can go into itself once. 3 can go into itself once. Then all we do is multiply straight across. 1 times 2 is 2. 5 times 1 is 5. Our answer is 2/5. I'll do the same thing here. I'll rewrite. We have -5/6 times -3/4. So a negative times a negative already should tell you we're going to have a positive answer. And even though 5 and 4 don't have a common factor, 3 and 6 do share a common factor of, again, 3. 3 can go into itself once. 3 can go into 6 twice. You multiply straight across. You end up with 5 over 8. That can't be simplified anymore, and it's of a positive value. That's what we do. Now, let's go to number 10. Okay, we're just going to keep on keeping on. When I go to number 10, I'm going to see that I'm going to keep my -3/10. I'm going to change my division sign to multiplication, and I'm going to flip my other fraction to 5 over 4. 2 negatives means I'll end up with a positive, so that's fine. There are no common factors here, but there is a common factor here. That common factor is 5. 5 can go into itself once. 5 can go into 10 twice. Then you multiply straight across. You should end up with 3 over 8, and that's as far as that's as much as we can simplify that one. 3/8. Okay. Now let's keep on keeping on. All right. For this one, change it back up. We have -2/3. Changing my division to multiplication and then flipping my second fraction. Instead of 1/2, it's 2/1. You simply multiply across. You end up with 4/3. Okay, that's still improper. So we know we need 3 pieces to make one whole. If we need 3 pieces, but we have 4 pieces, we definitely have 3/3, which is one whole. 4 minus 3 leaves us with 1 left out of 3. Therefore, our answer is -1 and 1/3. Number 12. Number 12, okay? 2 and 1/2 times -3/4. Okay, so we're going to have to do that walk around Texas, and that's cool. We could do that. We're going to walk around Texas. 2 times 2 is 4, plus 1 is 5. So now we have 5/2. We're going to multiply straight across. Positive times negative will give us a negative. 15/8. We can't leave it like that. So again, decompose. From here, we can yank out a -8/8 because we need 8 pieces, but we have 15, so we definitely have one whole. 15 minus 8 will leave us with 7. So we are left with basically -1 and 7/8. And that's our answer, -1, 7/8. Number 13. All right, number 13. We're going to keep our -8/9. We're going to change our division sign to a multiplication sign. And we're going to flip 4/9 to 9/4. Fortunately for us, that actually works out quite well. 9s share a common factor of 9. 9 can go into itself once. 9 can go into itself once. 4 and 8 share a common factor of 4. 4 can go into itself once. 4 can go into 8 twice. You multiply straight across. 2 negatives make a positive. Therefore, we have 2/1, or just 2. When we look at 14, it wants us to draw lines connecting the situation to the matching expression and correct solution. So let's read the first one. It says the water level drops. When I see drops, I'm going to put an arrow going down. That tells me that it's likely going to be a negative number. So the water level drops, let's say 6 inches over 2.5 days. By how much did it change each day? So if I'm thinking about that as an equation, to me, that's going to be -6 times 2.5, or divided by 2.5. Cool. I see that right here, so I'm going to draw a line that takes me there. Then, if I were to solve it, I'm going to have to do the walk around Texas, which means that I now have -6, basically -6/1 times 5/2. Okay, 5/2. Well, I see a common factor in my 6 and my 2. 2 goes into itself once. 2 goes into -6 3 times. Then it's just a matter of multiplying straight across. 3 times 5 will give you, well, negative 3 times 5 will give you negative 15 over 1, which is the same thing as just negative 15, and we can make that connection there. Okay? Number 2, it says Cassie deposits $2.50 each day for 6 days. Now, deposits means that those are positive numbers. So that means they are adding $2.50 each day for 6 days. That's going to look like 6 times $2.50, which is conveniently right here. 6 times 2.5, $2.50. We can do that pretty simply. 2.5 times 6, that's going to be 30. Carry our 3. 2 times 6 is 12 plus 3. That's going to be 15. Move the decimal 1. And that should be positive 15, which we see here. Now, our last one says AJ invests in a stock that drops. Ooh, there it goes. Drops down $2.50 each day for 6 days in a row. What is the change in AJ's investment? So if it's dropping $2.50 each day for 6 days, that means that there's going to be negative $2.50 each day for 6 days. That looks like this one here. Okay? Wait, I think I made a mistake earlier. Because I should have flipped that, huh? Yeah. I apologize for this one, y'all. That one actually should have went up here. I forgot to flip that second fraction, so that is my bad, okay? For that, I apologize. Please don't get upset. Made a mistake. I'm sorry. Because 6 times negative 2.5, that should be negative 15. So I made an error. That's my fault. I apologize. This is still the right expression. However, when we solved it, it should be right here. Okay? So I did 5 over 2, and I forgot to flip it. So that's what happened. So let's try this again. We're going to do 6 over 1 times 2 over 5. Then when we do that, yeah, that makes more sense. Then it's 12 over 5. If we decompose 5 over 5, 5 over 5, that's 5, 10. 2 over 5, but we're dividing a negative by a positive, so that's why this becomes negative 2 and 2/5. So I apologize for that, but this is how you would solve it. I forgot to flip that fraction, which is an easy mistake that you guys can make too, okay? So that's my fault. Anyway, that is multiplying, dividing rational numbers, at least part 1. So, hope you guys enjoyed it, and I hope it helps. See you later.